Everybody. Good afternoon. Thank you all for your participation here, present at the auditorium or online, and be welcome to the seminar of the Astronomy Department of IAG-USP. Today we have a special talk by Augusto Damineli, full professor of our Astronomy Department at IAG-USP. And I would like to, before the seminar, to share a few biographical information about Augusto. He obtained his bachelor's degree from the Physics Institute of the University of São Paulo in 1973 and got his master and PhD degrees from our institute in 76 and 79. And he's a professor of the institute since 1977. Is it correct, Augusto? 45 years, right, completing this year. And his research is in the field of massive stars, and his studies on the system Eta Carinae had a major impact on the world astronomical community. Some of his activities along his trajectory includes president and secretary positions at the Brazilian Astronomical Society, project scientist and member of the director committee of the Gemini project, coordinator of the astronomy graduate program of IAG-USP, postdoc researcher at the IAS Rome, and visitant professor of the University of Colorado Boulder. Currently, he's project coordinator of the Giant Magellan Telescope, and besides, he has always dedicated to outreach activities, giving big contributions to the dissemination of astronomy to all the Brazilian society. Augusto, thank you for accepting giving this seminar today. And he will present the talk, Eta Carinae, Paradigm Shift. Questions can be asked to Augusto after his presentation. And if you are following the seminar through the YouTube channel or Google Meet, you can also make questions. And I would like to ask all the colleagues following the seminar in the Google Meet to turn off microphones and cameras during the presentation. After the talk, there will be an event in honor of Professor Augusto Damineli, including a session of short videos prepared by his former students. So Augusto, feel free to start.
Okay, are you here now? So thank you guys for coming. I think that is the first face-to-face seminar, mask-to-mask, I must say. But most of the audience may be online. And a little tip, to see the animations, it's a little better to look to YouTube. But to make questions is most indicated to use the Google Meet connection. Well, so this is my backyard where I'm living now. Some of you have been already there. You see the star. I have Henrik Hartmann's collaborator in the exact same place. And I had also the visit from Kate Garmany in the old house. Now this is my backyard, and I'm happy to be there. And I hope to receive your visit in person at our ranch. I first want to talk, to thank for the support institution, my institution, IAG-USP, to the State Foundation FAPESP, and the Government Research Center, CNPq, and to thank also for the very large team of collaborators. I had a great advantage to collaborate with many people. And now my mission today is to show that Eta Carinae has shifted paradigm since the year 2000, more or less. And what this means? Well, we are always, so this is special for my grandson, Otto, to show how scientists work. We look to some part of the thing, and this one saying that it is the elephant, he doesn't see the whole thing. It's a snake, it's a wall, it's a palm tree, or a snake, so, etc. So everybody do incremental progress of technology, looking for particular things. And normally we do not have time to see everything together, so I'm now looking, we are looking to the big picture and trying to put together all the researchers. Because at some time, things shift the paradigm completely. And I think that we already reached this point. And this is what I am showing. I did not give full reference for the many works that conduct to this paradigm shift, because there are too many people. So, but what are the two paradigms? The old paradigm that everybody worked on before the year 2000 was that Eta Carinae was a single star, unstable, rapidly rotating, with huge wind, and underwent a wind eruption from the external parts of the star in the year 1847, 100 years before I was born. The new paradigm is binary stars, and let's show again. Binary star covered by an occulter, a coronagraph, and it was not a wind eruption. It was a true supernova explosion. It already went through a supernova explosion, which is the core of the star exploded, not completely. So these are the two paradigms, and I will try to show how this paradigm, new paradigm, started. So, but why Eta Carinae is important? So many people think that it is an exotic beauty, and not for astronomers. For astronomers, everything is peculiar. But Eta Carinae has had 600 papers published, 2,000 citations, and in part because it's a nearby object, only 7,500 light years. It is extremely luminous, 5 million solar luminosity, and it is representative of the most massive stars with the mass more than 100 solar mass. So this is why it's important, and you can imagine that I cannot make a summary of all those papers. So Eta Carinae is a special subject, like the sun. It's the star that is most of the observation in the night sky are done for Eta Carinae. Only the sun is more observed, more frequently than Eta Carinae. Eta Carinae, for our scientists, is essential to interpret the far universe. So these orange galaxies are in the foreground because they are close to us in time, so they are old and dead. But as we look to the fainter points, all those are galaxies. There are only 2 stars in these pictures. So you can look, you do not see the cross. So everything are galaxies. And everything that is blue is plenty of massive stars. Maybe 10,000, 100,000 stars like Eta Carinae. And so to interpret this far in time and also in distance objects, we need to know the most massive stars, and there is only a few of them nearby. Eta Carinae is the most known, so they are very, very, very extremely rare. And so we need to understand Eta Carinae to deconvolve those little points in 10,000, 20,000 stars, some greater, some smaller than Eta Carinae. This is why we need to know at least Eta Carinae very well. But why it is famous? Because it appears in the cover of many important news. So it's a cover story, but it is famous because of the physics. No, people do not understand physics. It is famous because the star did something unexpected. In 1847. So it was in the 1600s, a faint star, 3.5 magnitudes, like Kappa crosses. You look to the Southern Cross, and you see the Kappa crosses, and Eta Carinae was usually that star. But then, in the 1847, it reached the brightness almost of Sirius. So it was the second brightest star in the sky. And it was seen during the day. And this is important because the sailors use it to navigate looking to Eta Carinae during the day. This is why we have so many observations made by non-astronomers since then. Then it faded below the Nike limit, and then it's rising again. And people say, so it's going to do it again. You have a big show in the sky, in the southern sky. Unfortunately, I will show that this is not the case. So, but its fame came from this. It was named Great Eruption, that I will show that it cannot be anymore called Great Eruption. Eruption is something like geysers from the surface, not from the center of the Earth. Well, so the first shift in the paradigm of this so-called Great Eruption was done by people that were working with supernova. This is a supernova explosion, and those are the light equals. So we do not see the supernova, but we see, and this supernova exploded twice, do you see? So supernova do not explode always, once in their life. But the important thing about light equals is that if you take a spectrum in the light equal, you recover the information of the right time of the explosion, the color of the explosion, which is more important, and the velocity of the gas. So it's a time travel machine. So in our community, we had people that did the same thing for Eta Carinae. The thing is not so easy as in supernova, because the light echoes from Eta Carinae spread out a nebula that is very bright, the Eta Carinae nebula. And so you must be have a telescope to point at least twice. So this is a travel of this light echo. So you take a spectrum, you predict that the light echo will go to this. You take a spectrum, and then when the light echo reaches this, you take another and compare. This is what the group of Nathan Smith did. It involves a lot of telescopes. And they got this. So the nebula has this black spectrum. It is a narrow line. So for centuries, it's just this. But when the light echo crossed the telescope pointing, the spectrum was this noisy thing that you can put on top of it a true supernova, 2011, and you see this brown line is the real supernova that is just a supernova. It's not Eta Carinae. Eta Carinae is the noisy thing. You see that they match very well. And in place of the nebula, we see a light expanding at a speed of more than 10,000 up to 20,000 kilometers per second. Winds do not move mass more than, so dense wind move less than 1,000 kilometers per second. No way that a wind like of a great eruption, the great eruption, could not accelerate the surface of the star to this kind of velocities. And so it is not an event that occurred in the outer parts of the star. You need a real explosion, a real supernova. So 1847 was not a great eruption. It was a true supernova. And you see this blue line tells the temperature, and the temperature was about the temperature of the sun. And in fact, observers at the great eruption, they reported that the Eta Carinae went through a solar color. So we can match the light echoes continuous spectrum to the observations of almost 200 years ago. Well, how can a star do this? Explode, survive, and it certainly will be a supernova because it has almost 100 solar mass. It will die a second time at least as a supernova. So it's a recurrent supernova. We know that there are many recurrent novae, but it's another kind of phenomenon. And the mechanism could be peri-instability supernova when the temperature is more than 3 billion kelvins in the center of the star. It generates particles and antiparticles, and has a partial explosion. So the star rearranged and can explode many times. But this is just for stars very massive, and maybe Eta Carinae is not as massive as this. The second scenario, which is very popular today, is a binary merger. So two stars merged. But now we have already the first step for the new paradigm. We do not can call anymore great eruption. We need to call supernova explosion. So it's just to change a G for S, and it's a new, completely new paradigm. Well, during the supernova explosion, the homunculus was created. It's this beautiful bipolar nebula with tens of solar masses and the kinetic energy of 10 to 50 ergs, which is supernova again. The kinetic energy needs a supernova. Winds cannot do that. At the center, in the 50 years after the supernova, the star ejected a little homunculus. It is also a elongated shape, but this was the last thing that was created by the star, and is not related to the big explosion. It is a completely different, was the last one, and so there is no more room, I will show, for things people have claimed baby homunculus, which would be the third one, but no baby homunculus, I will show this. So this was the last. But before of that time, this is a Kimink's paper showing each color shows eruptions, events, before the big eruption that created the homunculus. So it had a very turbulent life before the supernova explosion. We don't know what happened. Maybe the thing that produced this is from year 1200 to 1800. Maybe this is part of the same phenomenon that finished with the supernova event. I will show a realization of this idea by Hirai from the Naismith group. And so there was a triple system, two close binaries, and a third star that was catching, and one of the stars was thrown inside. It's complicated. But it was saved, but the other small star went to a merger, and now we still have a binary. So this is star that merged, and the secondary star, which is very hot. This is a little cold and more luminous, and this is the homunculus. So this scenario is very popular these days, but it has a problem. For example, in the model by Schneider, when star merge, is very fast. 1 or 2 years, the star increases the luminosity very much, but then it stays stable for 1,000 years. And you remember that Eta Carinae did this drop, and now is going up, and some people say it cannot be a merger because a merger is more stable. And so this 1900, and so we are here, and this does not like the models for binary. But this is fake news. This light curve is not from the star. This is the second pillar for a paradigm shift. So this is fake, and we need to know what is behind. This is not done by the star. Well, the variation started to be understood after some of these strange things of Eta Carinae was that the high citation line, which is iron twice ionized, dropped to 0. And from time to time, very briefly, then I discovered Steiner, and I discovered that the most energetic line, helium-2, also did a very fast change. But those things were interpreted as linked to this crazy, weird star. So a crazy star can do everything it wants. But we did bring a very nice regularity from this phenomenon. So I think that this is my best contribution to this. In 1996, I discovered that it was a binary with a period 5.5 years, very stable, one part in 5,000. And here you can see my life following the periastron passage of this system. This is done in Brazilian telescope of the Pico dos Dias Observatory. So this is the model for the binary. This is the radial velocity shift. When you see a thing like this, every student knows that it is not a circular. This is not sinusoidal thing. So the crossing of the periastron is very fast, and this is a signature. And so I could model with Peter Conti and Dalton. And so we know very well what is inside the system is a binary system. Okay, so I will show this. NASA made this to the general people. So this is the homunculus.
New results from NASA's satellite-based ground-based and theoretical models are providing astronomers with an improved understanding of the system. At the nebula's heart lie two giant stars. The smaller of the two is 30 times the mass of the Sun and a million times brighter. The primary weighs 90 suns and shines 5 times brighter than its companion. Both stars produce powerful outflows called stellar winds, but the primaries is so dense it prevents astronomers from directly observing the star. The secondary's orbit is among the most eccentric known. Every 5.5 years, when the two stars swing toward closest approach, or periastron, they come about as close to each other as Mars is from the Sun. Where the stellar winds collide, temperatures reach hundreds of millions of degrees, hot enough to emit X-rays. But the X-ray emission shuts down near periastron when the smaller star is swallowed up by the dense wind of its larger companion. The X-rays gradually recover after periastron, but they do so a bit differently each time, suggesting structural changes in the dueling winds. Recent observations have helped theorists refine computer models of this interaction. Here, darker colors indicate lower gas densities around the stars, while the stars themselves appear as black circles. When the stars are far apart, the winds collide head-on, creating a huge cavity surrounded by 50 million degree gas. But near periastron, the secondary whips around the larger star, carving a tunnel through the primary's dense wind. The secondary star's rapid motion changes the collision zone from head to tail. The smaller star's faster wind flows out along the cavity it created and then crashes into the outward moving wind of its companion. From our perspective on Earth, the X-rays fade, then recover as the stars move apart.
Star is not crazy. It is doing what other massive binary does. So very close interaction. This is a commonplace in other massive stars. So not so dense as in Eta Carinae. So people need to do very good 3D models with new techniques, with new physics, cooling physics, to reproduce the light curve. But it's not crazy. It is just a massive interactive binary. And it's repeatable, is a damn repeatable star. But well, when you look to the light curve, you see that the star is going brighter and brighter and brighter and brighter. You say, oh, the star has it's crazy in some way. If I make a fitting in this, and I divide the observation by this fitting, which I did with Daniel's, my son, programmer, we get a very nice periodic oscillation. And the oscillation is because the star is not round. So the star, when you see from this, you see a peak. When we look tangential, we see a minimum. So some students should come from this and produce this. Is a good project. I think I will not have time to do this in the future, but it's a good suggestion for a research. Well, so the entire object is brightening and is going brighter. But from the year 2000, we started to monitor just the central core without the complications of the homunculus. And the star is brightening much faster than the entire object. So the homunculus plus the star is going up like this, but the star itself is brightening. So it brightened by 6 times in 20 years. So why the star is brightening more than the reflection nebula? So it should reflect this. Well, and there are reasons to expect that the homunculus should be flat. This is the mid-infrared observations. So the dust around the central star absorbs the light and remits the infrared. And in the infrared, since 1970, up to very recently, the observation shows that the luminosity of the central star is is constant. And so there is something that is cheating us, because this is very robust. And it's showing that the star itself is not doing this. This is a fake news. In X-rays also, we see exactly what is going on in the wind-wind collision. And you see that, except from instabilities that you heard in the NASA's movie, so the system is repeating, and the level of the X-rays luminosity is keeping constant. So the heart of the system is constant. And so the light curve has something that we need to understand. So people has been claiming that it is because of the mass loss rate of the winds from the primary star is decreasing. Okay? Here is the spectral line of helium-1, and it was like this when I started observing, and today it is like this. So it's decreasing. It looks like to be a decreasing mass loss rate. But this is because the guys that claim this are some of the blind people that are touching the elephant from just one piece. When I look to another piece, because if the wind, the mass loss rate is decreasing, the emission is decreasing. But the absorption also should be decreasing. And it is not. So the absorption was like this, and now is like that. So the emission is decreasing, but the absorption is also decreasing. No wind can do that, because if the mass loss rate is decreasing, it is getting more transparent, the emission decreases. But if it is more transparent, the absorption also decreasing. But it is increasing. And so this says that it cannot be a mass loss rate decreasing.
Augusto, 30 minutes has passed.
Okay, so the idea is that just on top of the star, there is a coronagraph. A coronagraph is like, when, for example, we see the sun. When the moon goes on top of the sun, you see the outside things coming up. So you can imagine that there is an occulter on top of Eta Carinae. So let's see what is a normal system like Eta Carinae without this occulter. So is Earth. The central portion of the system, which is the very luminous and has this spectrum. But the outer wind has fainter lines, broad lines. And in the case of Eta Carinae, there are the Weigelt clumps far from here that emits the narrow lines. And so when you add up everything together, you see just the spectrum of a typical LBD star, which is the central region. So this should be the spectrum of Eta Carinae. And how the dissipation coronagraph interfere in the system? So if you put something blocking the central luminous source, you see the outer things. So what we have been seeing are the outer regions with the central region blocked. But what happens if the central region gets if the coronagraphic dissipates. But first of this, there is a way to see the central star. Because there are clouds close to the system that reflects all those things together. And the spectrum that we see indirectly is exactly of a normal LBV star. So this is not Eta Carinae-like spectrum. This is so so some things you do not need to look directly. You don't see anything. You need to look the mirror or the reflection, and then we see a normal LBV. But when we point directly to the star, you see all those things that are the Weigelt, because you depress the central source, and the Weigelt clumps gets enhanced. So this is explanation why the spectrum is completely different from any other LBV star. Eta Carinae is thought to be a LBV, but with a spectrum that cannot be reproduced by any computational model. So we did the model from this reflection. So the star was like this in 1993. Look direct to the star. There was this very gorgeous spectrum of emission lines. Gorgeous, but it makes us blind and you cannot see the real star. 2 years ago, the spectrum was without all those emissions. The blue one is very close to the indirect view. And so the magic thing that the star is cheating us is because let's see how I can. And so there must be hã? Não, deixa ele vir. I don't know what happened. I think I need to.
Agora voltou. Agora tá.
Ele pulou para o final.
Tá. Ele entrou sem querer, eu acho.
Well, and so when we look straight to the star, the spectral lines are decreasing. When you look to the nebular reflection, they are constant. But we more trust on the reflect because there is this occulter. And it must be dissipating because we see more and more and more this spectrum getting similar to the other. Well, technical things. So Here is just to show that our models show that here are observations, and the dotted line is models. They do not agree perfectly. But all the emissions are going down, all the absorptions are going up. And this cannot be done by a decreasing mass loss rate. Well, here is to show that this coronagraph is very, very tiny. It's a little bigger than a star that is 1,000 times less than the homunculus. This is a hydrogen cyanide that are in absorption. So ALMA did show molecular absorption in front of the star at 60 kilometers per second. So this is the first indication that there is some absorption thing in front of the car. But for my surprise, I just got a paper by Zulema Abram from my institute. And she published this molecular map of dichloromethane. And you see those dashed things are a cloud of absorption. So I think that is the first indirect image of the thing that we stayed for more than 20 years looking in the data, in the spectrum, not in the image. So, and for example, this is for Zulema, for Abra. The occulter is to the east, a little to the southeast. When we compare, so this is the occulter. The occulter is not exactly on top of the star, little shift, but no problem. When we look to the ultraviolet, this is a more recent spectrum in the ultraviolet. This is the star, and those are the faint absorption. So there is still some material, but not anymore, as it was 20 years ago. 20 years ago, the absorption were very strong, and this is exactly in the position that Abram made the maps of the chloromethane. Well, and what do we predict from now to the future? So this is the star that is wiggling because it is distorted. And we predict that in 2032, the star will have not anymore the coronagraph, the occulter. And so the star will be a constant star. It will stop going up. Here is a movie made by USP for me. And it shows the dissipating coronagraph. You see, we see more the star, but you lose the beautiful things outside. But we are interested in the heart of the star, not in the dress. The dress is like... So, Eta Carinae is like a beauty dancing carnival. We know in Brazil. It's like this. But the beauty, use a mask to call attention for the dresses. So she's cheating us because she is occulted. And this is because we see the beautiful thing, the beautiful dresses. But as the the occulter dissipate, we'll get this. 2032, we'll see the beauty. It will not be so beautiful anymore. But we like this because we see the real heart. We see ultraviolet and anything. So there will be a new era of research for the central star. But with this model, we can look to the star that this is the light curve, and this is the star. So this was the star up to here. But then the nebula started to brighten more than the star. And now the star is brighter than the nebula. So if you go back to the records of the star, those are the brightness. If we correct the absorption, you get this light curve. So the great eruption was a little brighter than observations. But after the little homunculus, we have a flat light curve. And this is because of the distorted star. So in 1940, there was a 1 magnitude jump that people say, it's another time, same event as in 1895. It is not, because the star remained with the same exact brightness. So the jump was in the nebula. And from this time up to now, everything we see in the brightness is because of the intervening interstellar medium, because of the occulter. It is not the real. And so the jump in 1940 is in the nebula. So there is no room for the baby homunculus. That some people say that this was the baby homunculus ejection. There are many reasons why it cannot be. One is that. So if you correct for all these complicated things that happen here, if you take off the things that are in front of the star, it went to eruption, and then it flattened. So everything else is made by the interstellar medium. This is very, very similar to the model for the merger. So the merger in a triple site system is in good agreement with the observation to correct for the observation. And this is the last point for making a new picture, a new paradigm. So after correcting for the periodic things, do the binary system, and the general extinction decrease, Eta Carinae has been very stable from the last century. And so it is a stable, massive star. Well, so Eta Carinae is not a weird beast, but is just covered by all those stuffs that looks to be the star, but is not. You need to clean for the intervening circumstellar medium to see that we have a very common interactive star. So this is my view of the new paradigm. So, okay, I thank you very much for the attention. I am open to questions.
Thank you very much, Augusto, for this nice review, for this presentation. And now we have time for a few questions. So shall we start with Professor Zulema from Google Meet.
Thank you. Augusto, I think you didn't read my paper carefully. The absorption that I showed was in the Earth's atmosphere, not in Eta Carinae. The aim of the paper was to show that several of the absorptions that were supposed to be in Eta Carinae are really telluric lines. So the line that you show is not in Eta Carinae, it's in the Earth.
You say explicitly that dichloromethane, CHS2, is not produced by a telluric. I read that 10 times at least.
No. What I said is that the CNO is not telluric. Only the first ones that you show. All the rest are telluric.
Well, so you put the dichloromethane not at minus 9 kilometers per second, but at much larger shift. And HCN...
No. It's the CNO plus.
Well, I did copy your...
Plus.
So we can discuss these details. Because, for example, you say that HCN is not telluric.
Yes.
If you have one molecular absorption that was reported by Bourdieu, we have an indication of an absorption material, cold material in front of the star. So the details of the map of the absorption, I don't know. Why did you put those?
No, Augusto, but the line that you show, yes, the line that you showed is not the one of Rizzo. It's the one. It's another one. It's a telluric line.
So you mean that? I don't see.
The first one that you showed.
You made the map. You made the map of the telluric line. I cannot believe it. I cannot believe it.
Yes.
This is so. You say, well, you say explicitly that this is not.
This is a telluric line.
Well,
the upper one is real. The lower one is telluric.
Well, so maybe I misread by this line, but this is still valid from older paper that. So maybe we do not have a map of the occulter, but we know that there is an occulter because of the absorption. So it's a detail that we could discuss better in the future.
Yes. No, I agree with you that probably there is absorption, but not in the lines that I show.
Okay. Okay, we can continue. This is do not invalidate the arguments because. But we can discuss the details because ALMA will be very crucial in this subject. Thank you, Zulema.
Thank you. Let's move forward to another. We have time for a few other questions. So, Marcos Dias.
Augusto, I'm curious because you showed so many high excitation and high ionization lines that comes from the nebula. And then you show this molecular cloud that works like a coronagraph. So those high excitation lines are further away. Are they shadowed by the molecular clouds, or where the emission come from?
Well, our models show that the occulter is smaller than this spot, like this. So is 20 stellar radii.
Okay.
and the high excitation lines are way outside.
I see. Thank you.
Guilherme?
Professor, obrigado pela palestra, porque eu gostei muito, de verdade. Então, obrigado. Então, vou fazer a pergunta em inglês para registrar na gravação. My question is regarding the first part of the talk, regarding the stellar merger, because honestly, in my humble experience, every weird we see in stars, people say it's stellar mergers. So the question that I have is, how frequent do we expect that stellar mergers could cause something like that? Because I don't know how, what is the expected frequency for stellar mergers happening in the discovered galaxy? So this is basically the question. Is this event likely to happen? Because everything that is weird in stars that I see in the literature, people always say that it's stellar merger. So that is basically my question. I know this is not related directly to your work, but how likely this is to happen?
Well, massive stars always are formed in clumps of stars, and they grow eating the other stars. So when you have a massive star, most of the time you have two equally massive stars. So this is very, 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 very frequent you to have binary. But you have always a clump of small stars that normally are eaten by the massive stars in the beginning of the formation. And this is when the system was already formed. So it cannot be, it is not really rare, because in small stars it is rare because they are apart. But in massive stars, more common. And so it is one model, one possible model. Nobody says that is the true model, but it's a good idea, except that the light curve after the merger had this dip, and so some people say that it is not a merger because a merger is a high amplitude and then flat for thousands of years because the collapse is slow. And this is the case for Eta Carinae. So I cannot answer your question in terms of probability of a triple merger. But there are many, many models. This is not really a model. This is a movie made on thousands of models. It doesn't mean that it is one of the possible scenarios.
Sure. No, but I understand how it would be likely if we have, like, because of the physics of the fragmentation of the original cloud that gave rise to this to the original star. So I see, and I see now why this makes sense with the observations that there is this kind of occulter in front of the star when we observed it. So thank you.
Okay, thank you.
So because we are short of time, we will open for 2 short questions from participants online, and then we will pass to the second part of the event.
Yes, one I will read, and the other one can open the microphone. One is from Tasso Napoleon, and he is asking, Augusto, congratulations. Under your viewpoint, which were the most significant contributions that your Eta Carinae research has brought to our understanding of the evolution of high-mass stars as a whole?
Well, this was the recognized that it was a binary, because I was young at that time, 1989. I said, well, this star is a pop star. It's doing weird things. Astronomers live very long, so maybe I have some chance of picking up some of these very exciting weird things. And I started, because our observatory is small and you can observe just bright stars like Eta Carinae. But I can observe for a long time. I used to go then and to leave Patricia at home, because I want to first thank to Patricia, because she was a very nice person involved in my research time. giving me lots of support and giving me a happy life. I'm happy. And today more happy than before because I see people face by face, not like in my backyard in near Cunha. And so I thank very much to Patricia because she was, well, more than 20 years discussing with me. And it was the binary. They recognized that it was a binary. My most contribution, because at that time, it was not known that how many massive stars were binary. Some people went really very enthusiastic of this. This is why the paper has more than 400 citations. There are not so many Eta Carinae fans. The citation comes from other fields and in special people from binary, because when they said that even a beast complicated like Eta Carinae was a binary, so they improved the research of massive star and found, like Sana, for example, that more than 80% of the massive stars are known to be binary. So from that time to now, so when you talk massive binary, we have in mind 2. So my was not the first one, but was that even a thing very weird like Eta Carinae is recognized to be binary, we can find more, and they found. So I think that my best contribution, because this put a order on the chaos, and we found every 5.5 years those weird things exactly on time of the passage, periastron passage. And so it's not weird, it's just a clock, a clock, a clock. Then when we clean from this clock, we get a thing that is beautiful, more stable. And so the binarity is my main contribution. Thank you, Tasso.
So let's open for a last question. Please, Maria. It's from someone online.
Yes, it's not a question, it's just a comment from Pat Morris. Just add that I agree with Zulema. HCN and H13CN absorptions are real. Those trace the occulter. CH2Cl and CO absorptions are terrestrial. That's a comment.
Okay, thank you, Pat.
Okay, so let's thank again Augusto for this nice talk. Thank you, Augusto. So let's start the second part of our event. So we would like to celebrate in this occasion of Augusto's retirement his contributions to the astronomy department and to the Institute of Astronomy, Geophysics and Atmospheric Sciences. We'll start streaming some videos prepared by his former students, and also a collection of photographic memories involving Augusto trajectory. So Augusto, feel free if you want to comment during the presentation, the photos and the videos, and Richard, we can start streaming.
Bob Blanc is director of the Vera Rubin Observatory. And Denise.
Hi, Augusto. Congratulations. We're so excited for your retirement, and just wanted to share a few memories and thoughts of our time that we spent together and how we got to know you. So I'm Bob, and this is...
I'm Denise, and we met way back in the 90s in Boulder, Colorado.
So I wanted to start by saying it was just, it was pure luck that we met. We both came to Colorado to work with Peter Conti. We were working on different things. You were, and we just happened to be visiting Peter at the same time. You came up to work on Eta Carinae, the love of your life, other than Patricia. And I was there working on a new program to study massive star birth and clusters in the near infrared. And we got together and we started working together, and it was one of the most enriching and successful and enjoyable collaborations of my career. So I just wanted to say that and thank you. And then getting to know your family and being able to visit you in Brazil was one of the great pleasures of our life.
Yeah, that was so fun. Just the friendship we've had with you and Patricia over the past couple of decades, few decades, has just been wonderful.
And I wanted to say for sure, one of the things that was so enriching for my career was not only working with you, but your great students. So Liz Figueiredo, Cassio Barbosa, of course, and Felipe Navarrete, all three great collaborators and really an important part of my scientific career. So thank you very much for everything you did for me and introducing me to them and the collaboration that we were able to have for so long. And I hope it continues. I know you're retiring, but you're not going to stop doing science. So to finish off, we wanted to share a memory from Boulder.
One of our all-time favorites.
When we first met. You may remember we came over to your house and Brian was with us. Megan wasn't born yet. And I think Daniel and Flavia were there. And
Flavia was for sure there because Brian thought she was Pocahontas.
Yeah. And we had a great dinner, really lovely time. And then it was dessert time. And I believe this was the night that you and I think it was Daniel was there, because you discovered American whipped cream in a can. And I remember you doing this and being so excited. Congratulations, Augusto. We love you. Bye.
Bye.
Well, Augusto, congratulations. I can tell you that retirement is a good thing, although you'll find that out yourself pretty soon. Can't believe that it's been over 25 years that I've known you. I remember when I first met you back at GILA, must have been, about 1996 or so when you came, and Peter Conti sent you into my office to borrow a copy of the Binary Star book by Aiken, because of course you were working on what else? Eta Carinae. Over the years we've had such wonderful meetings. Of course, after GILA, there was the opportunity for me to introduce you to Jeff, and I really have to thank you, as I don't think I really ever have, for all that you did for him and his trips to Brazil. It certainly has influenced his life, and he and Beth are doing very well. We just saw them a few weeks ago. And of course, there was our trip to Brazil, which was spectacular, and I cannot thank you and Patricia enough for all you did for us. Visiting you in Cunha, visiting you in Sao Paulo, all of those things were terrific. Of course, we had the Conti Fest that we all enjoyed in 2008, and that was wonderful. Anyway, I hope maybe you'll get to travel. Maybe we'll see you again up here or down there. Hard to know. You'll notice that I'm not trying out any of my Portuguese, even though I now have a Brazilian grandson, I should say, and daughter-in-law. But we'll see what happens. Anyway, congratulations and take care, and hope to see you again.
Hello, Augusto. Pat Morris here, wishing you a very happy retirement and congratulations on a successful career. You and I met each other at Puerto Vallarta at the Hot Star meeting there almost, must have been 1993, 1994. And so in honor of that occasion, I came all the way to the beach to wish you a happy retirement. Well, okay, not really. I'm here on vacation anyway. But also would like to remind you that you refereed my first paper on Eta Car back in 1999, so thank you for that. It must have been a good report because I got published. And so, meanwhile, I hope to see you again, maybe at the next Hot Star meeting, hopefully at another beach. And of course, in the meantime, on Ted's Eta Car group calls. And so, again, happy retirement, and talk to you again soon. Cheers.
So, Augusto, I thought I'd give you an alternative interpretation of Eta Carinae, and it's sort of an astronomy folk story or love story. And it goes back to 1928 when the IAU first had its third major meeting at the Leiden Observatory. And there was an assistant astronomer, I think from Harvard College Observatory, Priscilla Fairfield, who was there in attendance. And her guide happened to be a person by the name of Bart Bach, who was a graduate student at Leiden and was escorting her around. Well, needless to say, by the end of the meeting, Bart had fallen head over heels. Bart had fallen head over heels in love with Priscilla. And indeed, he followed her back to Harvard. And by 1929, they were married, even though Bart, by the way, was 10 years younger than she. And it was quite, they actually worked together for well over 30 years, publishing many papers. But, during that period, Bart became a professor at Harvard College Observatory. Later, he went on to Mount Stromlo as the director, and then Stewart Observatory. That's where I met him. In 1975, Priscilla passed away, and Bart was quite heartbroken about it. The next year, he came to Cerro Tololo and came up to the mountain to actually walk around and see all the telescopes and meet all the astronomers. And when he came to my my telescope, he wanted to show me the various constellations of the Southern Hemisphere. And of course, the one that he was really enchanted with was the Mu, or the Aboriginal constellation that is basically dark clouds and that. And when he got done with that, he pointed to Carina. And he said, up there, there's a star called Eta Carinae. And suddenly he teared up and he quietly said, and that's where Priscilla is. And that's where I will be. So about 10 years later, Bart passed away. Now, Augusto, it took you another 10 years to really determine that Eta Carinae was a binary. And you interpreted it as two massive stars orbiting around each other. But in reality, it's Bart and Priscilla in their cosmological dance. Best to you.
I can go. So for me, I have Augusto. I had him as a supervisor and advisor and friend when I was through my grad and the first postdoc. So I just wanted to start that by saying that Augusto is one of the most extraordinary people that I've ever met. Since I've known him, he has been more than just an advisor that wanted data collected, reduced, and published. He's someone that I could always count on for anything. There's this episode or series of episodes when I was doing grad, the master, and the doctorate. I was always going to the OPD Observatory, which is the Brazilian Pico dos Dias Observatory. And I would spend nights over there, weeks observing. And I remember that every single night, every single day, at the beginning of the night run, I would always get a phone call from Augusto to check in on me. But actually, I was like, oh, okay, he's very concerned about my safety or if I'm doing everything fine. But now I know that he was just calling to make sure that I didn't make any mistake back then. And a few words about his personality. I can tell that Augusto's charisma is everywhere. Let it be a talk or a 5 minute conversation over coffee. It doesn't matter. you know he's a very nice guy. His accolades prove that what an accomplished professional he is. His colleagues, as co-workers and friends and family, can vouch for his pleasant personality. And I just wanted to finish by saying that it's an honor, a privilege to have been working with you, Augusto. And thank you for steering the pot in Eta Carinae. So that's all.
Tony here. I'm absolutely delighted to hear about your accomplishments and your retirement, although I'm sure you will not retire from our view at all. You'll be so enthused about continuing your great work on Eta Carinae that will be a myth. You know, I looked up in English what the word Auguste means. You know that word in English, it does exist, your name, without the O, of course. And I was very pleased to see that it's someone who is respected and impressive. And that hits it right on the head. And I remember I think we first met in person probably at the Rio meeting, the Rio IAU General Assembly in 2009, when there was I think Mike Corcoran organized a session on Eta Carinae, and I had just worked with him on RXTE data, X-ray data. And I was quite excited about all this. And later, when I met Noel in Montreal, he was a postdoc there, he invited me to join the group because he had just recently joined, I believe. And I did, thanks to him. And here we are. You have never ceased to impress me with your drive and your ability to come to terms with the binary nature of Eta Carinae. You discovered the period a few years back, a couple of decades, I think. And now you are well on the way to understanding the occulter, which is a very important aspect of this. So I wish you all the best for your retirement, and I hope to see much more of you. All the best. Cheers.
The next short presentation. So, dear Augusto, when you give presentations, what I like really most is your passion for astronomy and your persistence when you try to solve challenging questions. For example, the nature of the coronagraph. So this is my first point. And what I wanted to add is that, therefore, your work is a great inspiration and great motivation for me. So thank you very much. My second point is the following. It's a recommendation written on T-shirts of the outdoor company, the North Face. So I printed it in mirror image, so you can read it, hopefully. And you see it? Can you read it? The message is, never stop exploring. So I like it. Thank you.
Augusto, we've had lots of discussions, and I've always benefited by them. Your insight, your hard work, your great physical knowledge. I think we first met each other at the meeting in La Plata in '93, if I remember right. And I think you were there with Roberto Viotti, and at the time we were very confused as to what the nature of Eta Car was and what the variations were. And it's been a really great scientific adventure trying to puzzle all that out. And saying that the star we thought was so hard to understand and so variable is actually maybe pretty constant and stable and not so hard to understand, which is a great thing. I also have fond memories of the IAU meeting, and I guess that was 2009, General Assembly in Rio, which was lots of fun. And thanks for taking us sightseeing. I forget the name of that club. I think it was the Senator or something. And I'm still surprised Julian Petard ever made it back from there. So it's that was a very fond memory. But anyway, Augusto, it's been a real pleasure collaborating with you and learning from you and discussing things with you, and both from a high energy and a lower energy perspective. And congratulations.
Dive in next. Is that okay?
Go ahead.
Okay. Hello, Augusto. This is Ian Stevens from the University of Birmingham in the UK. I just want to add sort of my best wishes. Your work, your landmark paper in the mid-90s had a very profound effect on my research. With Mike and others, we then start looking at the theoretical X-ray light curve of Eta Carinae, and it worked very well, and that has led on to other work. I've worked on Eta Carinae sort of sporadically over my career, and it's been a real pleasure sort of reconnecting with you and with the Eta Carinae working group in the last few years. And I've been catching up on the object, and it's been tremendous to see the progress made, both with sort of current developments, understanding the coronagraph, and hopefully Eta Carinae is unveiling itself. So in the near future, we'll see a lot more. The object remains mysterious. You've made tremendous progress on the object. We still don't know. Did it start as a triple? Did it not? Who knows? So, mate, to wrap up, best wishes for your retirement. I hope, like some of the other members of the group, you continue to work post-retirement. It is one of those, retirement is one of those big challenges of life. It's easy to do badly and hard to do well. And I hope you find the right balance of less teaching, less responsibilities, and more time to feel doing interesting things. So best wishes from me.
So I've seen you many times in a conference or the Zoom meetings, and we had a lot of the interesting discussions, and thank you very much for that. So Mike already mentioned it, but actually I remember the meeting at in the Rio de Janeiro IA meeting, and we went to you brought us to the some power something that we had we danced together. That's a fun memory for me too. So thank you for that. I don't believe that you retire from the Eta Carinae science. I don't think anybody believes that. So so I think that I see you in the Zoom meetings or some other meetings in the future. So, but anyway, so this is some the retirement is one step maybe. So congratulations.
I think we met in person about a year ago when Tony was retiring. Now, Tony's retirement, he ended up supervising myself as a postdoc, several other people, taking on grad students and continuing work, and being one of the higher up people with the Bright satellites, and always advocating for more massive star research and more ways to look at things. Clearly, Tony's had a big influence on my career. And one of the things that I really liked that he did was that he was able to push me for better and better data. And your work on Eta Carinae's orbit and binarity in the 90s is fundamental to what we all do for Eta Carinae now. And I like to think that because of Tony's influence on myself, I kept pushing for more and more and better data. And because of that, I think we're now finally getting close, as you retire, to discovering the secondary in the spectrum. And maybe in the next 10 years, we'll have a good handle on that. So I want to thank you for sharing the observations of the last 3 periastra with me as I start my career and get that launched, and wish you the best in your retirement. If Tony's any kind of indicator, I'm guessing you're not going anywhere at all, but or Ted. But if you do decide to retire from astronomy, we thank you for all of your contributions. But I personally look forward to your contributions. And
so, well, I met Augusto at first when I was an undergrad student. So I had the course of fundamental astronomy with him in 2008. And then in 2009, I started working with him as an undergrad student. So, and since then, Augusto is playing like a huge role in my life as an astronomer, because everything I am and everything I got from now, I have his acknowledgement, and he's always saying, okay, let's do this, let's go further. I also I'm very fortunate to have Augusto as a friend, as a colleague, as a boss. He was never my boss, he was like a mentor. So I'm very fortunate to have him and part of my life. And well, I have so many experiences with him, so many things that I could share. Like we also had lots of interesting discussions about astronomy, every aspect of astronomy, every aspect of life, either at the University of São Paulo or at Cunha at his farm. So it was very, very good having those kind of experience with him, sharing interesting discussions on Eta Carinae, on the death of massive stars, at the birth of massive stars, which is the area I'm focused right now. And well, I also printed a 3D version of Eta Carinae here, so it's always on my desk, reminding me where everything started. And yeah, so thank you very much, Augusto, for all your contribution over at least in my life, over the past decade. And astronomy, your contribution in astronomy is fundamental. So thank you very much for that.
Yes, and thank you very much, Augusto. So actually, you're getting a promotion here. You're joining the other three of us emeriti, Gert, Tony, and myself, to become an emeritus. And that means you're going to keep working on the Eta Carinae along with us all. So everybody together, best wishes and many more papers.
Yeah.
Best wishes, Augusto.
Best wishes, Augusto.
Enjoy.
Congratulations.
Como colaborador, eu conheci o Augusto ainda durante a minha graduação em Biologia, quando eu ajudei na organização do curso A Vida no Contexto Cósmico, que me deu uma visão da vida como um estado de organização da matéria, até porque ela é feita dos elementos mais comuns que tem no universo, como se fosse quase um lixo das estrelas, como o Augusto fala. E depois eu tive a oportunidade de fazer colaborações mais técnicas com ele, depois do meu doutorado em Biologia Computacional, inclusive com a famosa Eta Carinae, onde eu consegui usar técnicas que eu desenvolvi e aplicava para análise de ritmos biológicos, para análise dos ritmos da Eta Carinae. Então, de ritmos biológicos para ritmos celestes, para mim foi bastante fascinante, e onde eu descobri dois outros componentes, além do ritmo famoso que o Augusto descobriu, esses dois outros componentes periódicos instáveis, e o que foi uma grande honra, dado a importância desse estudo. E também, como filho, eu ouço falar da Eta Carinae desde pequeno. Eu lembro até hoje que meu pai já chegou até a me pagar um dinheirinho para colocar uns dados na planilha. Isso me deu uma sensação de acessibilidade da ciência, de proximidade. Eu não imaginava que eu ia participar de verdade de uma colaboração, mas essa sensação ficou muito forte em mim. E não só acessibilidade, mas também um fascínio que eu ouvia as pessoas tendo quando ele descrevia coisas da astronomia. Por exemplo, eu lembro até hoje dele falar, por exemplo, um átomo de cálcio que está na sua unha, né? Tem subpartículas quânticas que uma hora estão aí nesse cálcio, e em uma fração de instantes infinitesimalmente pequena, essas subpartículas estavam em outros lugares do cosmos. Então, isso pintava um quadro de que você, na verdade, é um roda-moinho de matéria que, em média, está aí. Né? E eu achei isso fascinante, me dava uma sensação de pertencimento cósmico. E depois, ouvi muito falar do Carl Sagan, quando eu comecei a ler e ouvir, eu gostava mais do jeito que meu pai falava, porque tinha uma convergência dos temas, mas é como se eu tivesse o meu Carl Sagan pessoal, que falava as coisas de um jeito que eu achava muito apaixonante. Então, como pai, eu também tenho muito orgulho, porque o neto cresceu com uma paixão grande pela astronomia também, pelo espaço, né, filho?
Essa daqui é a Baianstein, que nesse caso a Eta Carinae.
Você tem muita curiosidade sobre o universo?
Sim, mas tipo assim, eu também não mais só sobre o universo, também sobre como surgiu o universo.
Parabéns, Augusto!
Olá, meu nome é Elisandra Figueiredo Cipriano e sou professora doutora do Departamento de Astronomia, Geofísica e Ciências Atmosféricas da Universidade de São Paulo. E se hoje ocupo essa posição é porque no passado alguém acreditou em mim. E esse alguém foi o professor Augusto Damineli. Eu fiz todo o meu ensino fundamental e médio em escolas públicas. Quando decidi fazer vestibular, e isso não foi imediatamente após ao final da escola, optei por Física e fui aprovada na Unesp de Guaratinguetá, num curso que, apesar de ser praticamente um bacharelado, é oficialmente uma licenciatura. Durante minha graduação, apareceu uma oportunidade de estágio nos observatórios das Ilhas Canárias e foi nesse estágio que eu descobri a astronomia e decidi que queria dedicar minha vida à astronomia. E foi aí que minha história com o professor Augusto começou. Com essa ideia em mente, procurei o IAG e fui recebida pelo professor Augusto. À época, o departamento de astronomia não tinha praticamente alunos vindo de cursos de licenciatura, ou mesmo de uma universidade com pouca tradição. Apesar disso, o professor Augusto aceitou ser meu orientador e isso abriu as portas para o que seria o restante da minha vida profissional, pelo menos até o momento. À época, eu estou falando de 1999, o Brasil se preparava para os telescópios Gemini e havia uma ênfase crescente na astronomia no infravermelho. Augusto era um dos poucos astrônomos com alguma fluência nesses comprimentos de onda e me apresentou essa área. Essa técnica do infravermelho seria aplicada no meu mestrado, doutorado, para a determinação de distâncias espectrophotométricas de regiões H2. Essas, por sua vez, seriam usadas para mapear os braços espirais da Via Láctea. Esse projeto já estava em andamento com grupos de pesquisadores dos Estados Unidos, colaboradores do professor Augusto. E por conta desses contatos do Augusto, tive o privilégio de passar os 2 últimos anos de meu doutorado no Cerro Tololo, em tempo parcial, participando dos primeiros anos incríveis do telescópio solar. Depois dessa época, fui fazer um pós-doc no Reino Unido, na The Open University, para trabalhar em um satélite japonês com foco no infravermelho médio, o Akari, sempre seguindo o caminho do infravermelho, caminho esse que fui guiada passo a passo com os ensinamentos e o encorajamento do professor Augusto. Em paralelo a tudo isso, o professor Augusto sempre valorizou e estimulou todos os seus alunos a interagir com a sociedade através da difusão e da divulgação científica. Augusto é um divulgador da ciência excepcional e muito inspirador. Para quem escuta falar da astronomia, em especial na estrela Eta Carinae, é praticamente impossível não se encantar. Em retrospectiva, eu posso dizer que esse respeito profundo que o professor Augusto tem pela difusão do conhecimento, para mim, foi o aprendizado mais importante que ele gentilmente me ofereceu. Eu diria que foi um dos gatilhos para a segunda grande mudança que veio no futuro da minha carreira, e a escolha pelo ensino e a divulgação da astronomia. Enfim, esse foi o início da minha carreira na astronomia, e tudo começou com o acolhimento que recebi do professor Augusto enquanto uma jovem estudante. Hoje, estou bastante feliz e madura com as minhas escolhas profissionais E queria ressaltar que isso tudo só foi possível porque lá atrás, no final do milênio, alguém acreditou numa jovem vinda da escola pública e de um curso superior então pouco conhecido, e esse alguém foi o professor Augusto. Muito obrigada, Augusto.
Bom dia, Augusto. Bom dia, amigos do IAG. Augusto, fiquei sabendo há alguns dias que você vai se aposentar, não sei se é verdade isso ou não. Então falaram para mandar o vídeo, eu estou mandando mesmo assim, mas ainda estou meio que duvidando que esse dia chegou mesmo. Augusto, queria começar te parabenizando pela sua carreira, pela sua brilhante carreira. Você é o cara e foi o cara durante muitos anos nessa área de estrelas massivas e clusters. O que eu vou poder te dizer no dia de hoje que já não foi dito durante essa comemoração do lado profissional? Acho que muito pouco. Acho que já foi coberto a maior parte das suas brilhantes descobertas, da sua carreira e outras coisas. O que eu posso dividir com você e com as pessoas que estão nos vendo hoje é mais como você me impactou na minha carreira, no lado pessoal. E esse impacto foi enorme. Como você sabe, são 3 pontos que eu queria te relembrar e te passar hoje. Um é a minha admiração por você, que é enorme. O segundo, a minha gratidão por tudo que você fez pela minha carreira, por todas as oportunidades que você me deu, todas as pessoas que você colocou na minha frente, tudo que você me ensinou com a maior paciência ao longo dos anos. E aí você não teve nenhum problema, né, de me ensinar o que você sabia. Eu diria que toda a direção que a minha carreira se foi, tudo que aconteceu, de uma maneira ou de outra, direto ou indiretamente, foi ligado às oportunidades que você me deu. Por isso eu sou muito grato. Histórias que a gente viveu ao longo desses anos foram muitas, né, Augusto? Você sabe. Viagens para linear, observações, a gente se conheceu. Você foi uma daquelas pessoas, né, Augusto, que a gente conhece. Você conhece a pessoa antes da pessoa conhecer você. Eu vou te explicar isso. Eu conheci você lendo a revista super interessante, quando você escrevia, né, na seção lá, né, sobre astronomia, 1995, por aí, se eu me lembro bem, ainda era uma criança. E quando eu te conheci profissionalmente, digamos assim, dos altos depois dos meus 18 anos, para mim foi meio que um sonho, né? Você encontrar com a pessoa que você tanto admira e que você tanto leu sobre o assunto. E foi assim que começou nosso relacionamento. Você aceitou me orientar na iniciação científica e foi um período muito, muito gostoso para mim. Depois, isso continuou durante o doutorado. Foi uma época fabulosa da minha vida que eu vou guardar com muito carinho. E do fundo do meu coração, eu queria te desejar o melhor para o resto da sua longa vida, espero, Augusto. Você já me disse várias vezes que você não ia parar completamente a pesquisa, que você ia continuar trabalhando. Isso eu vou com certeza continuar acompanhando os seus resultados, a sua carreira, no que quer que você vá se dedicar, né? Se talvez continuar com a Eta Carinae, não sei. E é isso, Augusto. Um abraço, um beijo e aproveite o dia de hoje que você merece muito. Augusto, o terceiro ponto que eu queria levantar hoje você sempre foi uma pessoa com uma facilidade nata enorme de sintetizar assuntos muito difíceis em uma pílula, em uma sentença, uma palavra. E você fez isso de uma maneira magistral, seja com os resultados de Eta Carinae, seja com a divulgação científica que você tanto se dedicou, você foi tão brilhante. E o que poucos sabem também é que você também foi um grande filósofo para todos nós que interagimos com você, e você sintetizava esses conceitos difíceis da vida em uma sentença. Eu me lembro de algumas, me lembro bastante da filosofia que você dividiu comigo, com os meus colegas, nossos colegas, quando você queimou o seu dedo, queimou a sua língua e sintetizou como que aquilo iria impactar o seu futuro próximo. Outra coisa que me marcou muito também foi quando eu estava no começo do doutorado ainda, a gente queria rodar mais modelos, tudo. Acabamos comprando um segundo computador para poder dar uma acelerada na tese, né? Tava ficando muito devagar. E eu lembro muito bem quando você virou para mim, estava com os 2 computadores ali trabalhando, estava uma confusão, a zona, e você virou para mim e falou: Zé, ter 2 computadores é igual ter 2 mulheres, viu? Melhor você se livrar de um desses computadores. E foi uma ótima sugestão, realmente, peguei um computador só, terminei a tese e foi assim que terminou. Augusto, de novo, queria te parabenizar no dia de hoje, deixar a minha admiração por você e a minha gratidão por tudo que você fez para mim. Muito obrigado.
Hi, Augusto. Congratulations.
Head of the department, Professor Gastão Lima Neto, and in the sequence to the director of our institute, Professor Ricardo Trindade. Por favor.
Thank you. Hi, everybody. It's a great pleasure to be here. It's an accident because I'm now in the role of the head of department of the Department of Astronomy, but it really gives me a great pleasure to thank Augusto for all his huge contribution to the department, to the IAG, to USP, to science in general. We heard a lot about his breakthrough work on Eta Carinae and massive stars, evolution of stars that gives us our elements, our chemical elements. And we also heard about his engagement in forming new students and professionals, astronomers. We heard about some of his ex-students here. And we also heard about his role as in the outreach of science, his work that's very important, especially nowadays that we live in a moment where science is perhaps not so well understood by the population at large in our country. And I'd like to remember that Augusto wrote a book that's Fascínio do Universo with our late colleague João Steiner, and it's one of biggest hit in our department site. It's probably, I think it's the most downloaded book we have here at the department. It's a really impressive thing. And what also I would like to remember is that Augusto also had a role in the administration of the university. It's something that sometimes we forget, and we give a lot of time to do that properly. And Augusto was at a moment coordinator of our graduate program. He was head of the department also, and outside the university, he has a very important role in the Giant Magellanic Telescope. And he started that a few years ago. He's still doing that. And, well, I cannot cite everything that Augusto did. It would be a whole seminar here. And, again, it gives me great pleasure to thank all the contribution that Augusto gave us. It's very important for the department. The department is actually the sum of everything that we do, and the contribution of Augusto is remarkable. So I'm happy that although Augusto is retiring, he has to, it's the law, he has no choice, but in fact, he's still with us. He's joined in our senior program. He will be seeing him, I hope, every day or almost every day here at the corridors of our department. And so as it ended the slides of the photos, I would like to also, I hope that you still have, you will have a bright future here at the department. So thank you again, and I will pass now to our director, Ricardo Trindade.
Thank you, Augusto.
Thank you. Here, I'm also here by accident, just like it seems Eta Carinae as well. So what I wanted to say is that the Institute, since some years ago, decided to give as a recognition, a medal to all those that have contributed a lot to our Institute. And that's your case, Augusto. Since I was a kid, I was also reading Super Interessante, and I also had contact with Damineli's text, and then I'm very proud to be here and to be able to give you this prize as a recognition of all your achievements, but also for your contribution to this institution. So it's not only because you're this great scientist and this great communicator, but also because you have really gave a very important contribution to this institution, to this university. So please accept this as an honor.
Thank you, Ricardo. Thank you very much.
Augusto, would you like to say some words? Please.
Well, I talked too much today. So I want to thank you guys from the Institute, and especially because of today. It is really very important. It's sometimes you feel that you mean something for the other people, and for the institution. And so receiving this medal is not because of the medal, but because I will leave it in my desk, but because I will remember that people enjoyed my things that I have done. I could have done more, maybe, and better, maybe. But what the few things that I have done was so well received that encouraged me to continue doing. But I want to thank again to Patricia, because Patricia was a nice person, talking to me with my research. She's a physicist, and I could tell every day the problems I am facing and could not resolve, and the other days so she accompanied the millimeters. I progressed every day, and she did a really very good job on the International Year of Astronomy. She did a very nice job, and she took care of my homepage, because I am not very good on computational things, so communication. And the first time I had a prediction of Eta Carinae, I was in Boulder, and I said, I need to tell something, but I could not go to say that the next year, on December, the 10th of December, Eta Carinae will shut down. Because people don't like things that shut down. They like people that explode. And she made to me the first blog I knew about, a blog where we used to put all the new data for more than a year. And then, December 1997, when she put the new results, I received congratulations from all over the world. And the people that work in newspapers, the journalists, from India, China, England, The Economist, the Denver Post. So I received it. People were watching the homepage. So I could not stay telling that, look, 10 December 1997, this thing will go to Periastron. So after some time, people will not follow you. But in the homepage, and so it appeared in the sky telescope. So so she was very important for by beginning of the new era of interest in Eta Carinae in the broad community, because they were following the data, where the data. So it was an interesting experience to connect science with people, because in some newspapers I received the copy. Only my name and Eta Carinae could I read, because it is in Arabic, in Chinese. So it was very fun. And so communicating is make a difference for me, for my research. Not just I gave understanding and funning talks to the people, but I received back very strong input from the community. So I thank you very much.
Now let's close this event, this celebration. Thanking again Professor Augusto and all the presents here at the auditorium and online. And I would like to invite everyone present to join a coffee break that's being served in the external side of the auditorium. So let's thank again Professor Augusto and all the presents.